Hello everyone, welcome to our previous year question series. So these are the questions related to your CBSE class 12 physics chapter 2 electric potential and capacitance. Okay, let's start the session. So first question is the physical quantity having SI unit Newton per coulomb is what? Newton per coulomb. Remember, Newton is the unit of force and coulomb is the SI unit of charge. And we know F by Q is equal to E. That is your electric field. So answer is electric field intensity. E means electric field intensity. Yes? Okay. Next is our question number 2. A proton released from rest in an electric field will start moving towards a region of dash potential in the field. Okay, suppose let us draw, this is your uniform electric field. Yes, this is your uniform electric field, and we know direction of electric field is from positive charge to negative charge. So let's think that here is your positive charge and in right side there is your negative charge. That means this is your higher potential, negative charge is lower potential. Yes, and a proton is placed at this point. So as per the question, in which direction proton starts to move? This higher potential will repel the proton. Okay, and lower potential means negative, that will attract the proton. So this is the direction of motion of proton. So a proton released from rest in an electric field will start moving towards a region of dash potential in the field. So towards a region of lower potential. Yes, so answer is towards a region of lower potential. You can write the answer towards a region of lower potential, or you may write towards a region of decreasing potential. This is your answer. Okay. Yes. Next, come to question number 3. The work done in moving a charged particle between 2 points in a uniform electric field does not depend on path followed by the particle. Yes. So as per the question, let's draw. I know this is your 1 mark question. Okay, these questions are related to only 1 mark. So for better understanding, I am going to draw the diagram. The work done in moving a charged particle Q between 2 points in a uniform electric field. Let this charged particle, okay, our aim is to shift the charged particle Q from A to B. Does not depend upon the path followed by the particle. What's the reason? Yes. So remember, this work done, we know W is how much? We know delta V is equals to, we can say delta V is equals to work done per charge. So W is equal to how much? W is equal to Q into delta V. That means Q into V final minus V initial. And in the formula for potential due to point charge, potential due to point charge is, that is your K into source charge divided by R. That means R is the what? R is the position. R is the position of point charge with respect to source charge. Yes, R is the position of charge with respect to source charge. That means this work done depends only on the initial and final point position. Yes, from this we can write this work done depends only on initial and final point position. Yes, yes. So it is independent of, type of path followed. Type of path followed by charge particle, or simply we write type of path followed. Yes, since it is a scalar. Okay, let's think about the diagram. V equal to KQ, where let this is your source charge Q at a distance R from the source charge. A point P is there. So what is the potential at point P? Potential at point P is K into source charge divided by R. R means it is the position of the point P with respect to source charge. Yes. So in this formula, W is equals to Q into V final minus V initial. This potential, yes, does not depend upon the work done, depends only on the initial and final point position. So it is independent of type of path followed. I hope it is clear to all of you. Okay. So our next question, question number 4 is, Draw equipotential surface for an electric dipole. Yes, one of the interesting question. Draw equipotential surface for an electric dipole. Electric dipole consists of two equal and opposite charges. Yes, equal in magnitude. Yes, opposite in nature. So this is your positive charge. This one is negative charge. So how to draw the EPS? EPS means equipotential surface. The diagram is something like this. Okay, EPS, they do not intersect with each other. You have to draw the diagram in a very systematic manner. Okay, so this is your diagram as per the given question. Yes, so this is the equipotential surface diagram for an electric dipole. All of you go through the diagrammatic part related to your electric potential chapter. Yes, next question. So question number 5, draw the equipotential surface EPS due to an isolated point charge. Yes, so isolated point charge, let us consider this is your isolated point charge, means single charge particle. So what is the nature of equipotential surface? That is the spherical in nature, but you have to draw the diagram. So how to draw? Now see, so don't think that you have to draw only the sphere in such a way that, now see what I am going to draw, see it properly. Yes, this is the diagram. So in this diagram, all of you see the distance between, the perpendicular distance between two equipotential surface gradually increases. Clear? So what is the reason? You all know it. E proportional to electric field intensity is proportional to 1 by dr. What is dr? Always remember, E is proportional to 1 by dr. What is dr? dr is the perpendicular spacing between two consecutive EPS. dr is the perpendicular spacing between two nearby EPS, two nearby equipotential surfaces. Yes, so as from the point charge electric field is gradually decreasing, electric field decrease होगा तो dr, the spacing between two EPS, that will increase. Yes, due to this reason you have to draw the diagram like this. Okay, most of the students are drawing the diagram like this. Simply they are drawing the spheres around the charge particle. That is not perfect actually. Yes, this is about your question number 5. So next is our question number 6. Does the charge given to a metallic sphere depend on whether it is hollow or solid? Give reason for your answer. Suppose this is your metallic sphere. Yes, so when we will give charge to it, what will happen? Then all the charges starts to reside on its surface. Remember this thing. So when extra charge is given to this sphere, metallic sphere, then all the charges starts to reside themselves on the surface of the sphere. So when charge is given, so what we have to write? When charge is given, then it resides on its surface. On its surface means on the surface of metallic sphere. Okay. Thus charge given to solid sphere. Thus charge given to solid sphere. Charge given to solid sphere does not depend upon whether it is solid or hollow. Whether it is solid or hollow. Remember, CBSE is asking such type of tricky question. Yes, so go through the chapter properly. After that you can give the answer. Okay. Next is our question number 7. A point charge plus q is placed at point O. That means plus capital Q behaves as your source charge. It is at O position. Yes, is the potential difference VA minus VB is positive, negative or 0? Let's see. This is very very conceptual. Yes. So here this is your point A, another one is this is point B. This is your point A, this is your point B. So potential difference between VA minus VB is positive or negative, we have to think. Yes. Now see, the position of point A with respect to source charge, let it be RA. RA is the distance of point A with respect to with respect to source charge. Then RB is the position of point B with respect to source charge. This is RB. Which one is greater? We know from figure it is clear that RA is less than RB. Yes, but potential at A, that means potential at A due to plus Q charge. This is your potential due to point charge. Again we can find potential at B due to this plus Q source charge, potential due to point charge. We know potential due to point charge B is equal to K into source charge, that means plus capital Q divided by distance of that point of observation from source charge. That means V is inversely proportional to R. V is inversely proportional to R. So as RA is less than RB, so potential at A is greater than potential at B, which implies VA minus VB, that means greater minus lesser is positive. Simple answer. Yes, I hope it is fully clear to all of you. Yes. Yes, next come to question number 8. A charge Q is moved from a point A above dipole, from point A above the dipole, here it is your point A, dipole of dipole moment P, to a point B below the dipole in equatorial plane. That means this AB represents your equatorial plane. Yes, so find the work done, equatorial plane without any acceleration, it is moving. Find the work done in this process. So as this is your minus Q charge and this is your plus Q charge, and AB represents the equatorial line position, and we know that equatorial potential due to dipole, electric potential due to dipole at a point on its equatorial line. What is that answer? V equatorial is 0. So for dipole V equatorial is equal to 0. That means we can say V at A is equal to V at B. Potential at A equal to potential at B equal to 0. Question is asking that find the work done in this process. A charge particle is moving from A to B. So that means work done, we know work done in moving the charge from A to B divided by that charge which is moving is equal to VB minus VA. As per the potential difference formula, VB minus VA. Question पूछा क्या? Question is asking about the work done. So W A to B divided by Q is equals to VB is equal to 0 minus 0, that is 0. So work done in order to move the charge from A to B is equals to 0. Yes, it is a very simple question. So always go through the theoretical part. So electric potential at a point on due to dipole at a point on its axial line, what is the formula? Then electric potential at a point due to dipole at a point on equatorial line due to dipole, what is the formula? And in general formula, electric potential at any point due to dipole, that answer is Kp cos theta by r square minus s square cos square theta. So like this you have to remember the theoretical part formula. Okay, formula related to theoretical part. Yes. Yes. Next come to our question number 9, one of the finest question. Why are electric field lines perpendicular at a point on an equipotential surface of a conductor? What is the reason behind the perpendicularity of electric field lines with respect to EPS, equipotential surface? Simple. In mathematical you have to show actually. So what you have to write? In an equipotential surface, as per the properties of equipotential surface, we all know that in an equipotential surface, we know work done by on moving the charge from one point to another point on an EPS, that is 0. Yes, we know W is equal to force dot displacement. So F vector dot ds vector. Let this is your equipotential surface. Let us consider there are 2 points, A point and this is your B point. and the displacement is dx vector. Yes, okay. Our aim is to move the charge q naught from A to B. So what will be the work done? F vector dot ds vector, that is 0. Okay. Then we know what is F vector. We know E vector is equals to F vector divided by q naught. That means we can write F vector is equals to q naught into E vector. So instead of F vector, I can write q naught into E vector dot ds vector is equal to 0. That means E vector dot ds vector, E vector dot ds vector equal to 0. And as per the properties of dot product, if two vectors are perpendicular to each other, then their dot product is 0. That means E vector is perpendicular to ds vector. We can say E vector is perpendicular to ds vector. What is E vector? E vector means this is your electric field lines. Okay, E vector means this is electric field lines. And ds vector means what? ds vector or dx vector, jo bhi. Okay, let mark it as ds vector. So this is your equipotential surface or surface of conductor. Surface of conductor. It is a part of surface of conductor, na? So this is your answer. Like this, you can show that why electric field lines are perpendicular to equipotential surface. I hope it is very, very clear to you. Okay, next come to our question number 10. 2 point charges q and minus 2q are kept d distance apart. Yes, so this is suppose q and this is your minus 2q. So this one is q, this is your minus 2q. They are kept d distance apart. Separation between them is d. So question is, find the location of point relative to charge q. Relative to means with respect to charge q, at which potential due to the system of charges is 0. Let the point P is there in between q and 2q, q and minus 2q, at which potential is 0. So with respect to q, let the position of point P is x. So with respect to minus 2q, the distance of point P will be d minus x. Yes, so as the potential at P is 0, according to question, potential at P is equal to 0. That means potential is a scalar quantity. So potential due to plus q charge plus potential due to negative minus 2q charge, that is 0. So what is the answer? V positive is k into source charge with sign divided by distance plus k into minus 2q divided by the distance is d minus x, that is equals to 0. Then we can write, next we can write it as, so k, which implies k into small q by x is equals to k into 2q divided by d minus x. Yes, okay. So next is k cancelled out, q and q cancelled out. After cross multiplication, we will get your 2x is equals to d minus x. So 2x plus x, that is 3x is equals to d, which implies x is equals to d by 3. So relative to plus q or with respect to plus q, the position of point P is d by 3. Yes, at which electric potential is 0. One more question. Okay. Okay, next question is question number 11. The figure shows the field lines of a positive charge. Is the work done by the field? Very, very important question. Listen it properly. It is asking about work done by the field in moving a small positive charge from q to p is positive or negative. Okay, forget about the question. What is the work done in order to move the charge from q to p? So what is the formula? Potential difference formula is, remember, V final minus V initial is equals to work done in moving the charge from initial to final by q naught. This is your general formula. So to move the charge from q to p, so what we have to write? Work done from q to p divided by q naught is equals to potential at p minus potential at q. Clear? Q is our initial as per the given question and p is our final. Very good. Next, so what is the value of work done from q to p? Work done from q to p is equals to q naught into v at p minus v at q. Remember one thing, this work done is your external, W external. Yes, work done by external force. Yes, this is your work done by external force. Okay, so now see P and Q. See the diagram. From this source charge, the distance of P is smaller than the distance of Q. That means we can say this is suppose your source charge. At a distance Rp, point P is there, and at a distance RQ, point Q is there. Yes. So which one is greater and which one is smaller? So Rp is less than Rq. So potential at P will be greater than potential at Q, because potential is inversely proportional to R. So V at P is greater than V at Q. That means Vp minus Vq, that is your greater minus lesser, is positive. That means I can say W external is equals to positive. But question is asking about work done by the field. We know work done external is equal to negative of work done by conservative force or work done by field. Simply you can write the negative of work done by field. So W field कितना होगा? W field is equals to negative of W external. But W external is positive. So negative of negative into positive is negative. So final answer is work done by field. The answer is negative. Keep it in mind. Keep this thing in mind. So negative is your answer. This is our answer. It is a very, very important question. Okay. Yes. So next question is, for any charge configuration, the equipotential surface through a point is normal to the electric field. Justify. Again you have to write like this. Previously we have discussed actually. On an EPS, simply you have to write on an equipotential surface, work done in order to move the charge from one point to another point on EPS is equals to 0. W is equal to F vector dot dx vector equal to 0. F vector is Q into E vector dot dx vector is equal to 0. That means E vector dot dx vector is equal to 0, which implies electric field is perpendicular to dx vector. So E vector means electric field lines and dx vector means your EPS. So both are perpendicular to each other. Okay. So question number 12 is finished. Next come to our next question. Next question is asking, what is the geometrical shape of EPS due to a single isolated charge? Already we have discussed. Yes, this is your single isolated charge. The equipotential surface is spherical in nature, but you have to draw the sphere in such a way that the dr means the perpendicular spacing between two consecutive equipotential surface, that should be in increasing manner. Yes, because E is proportional to 1 by dr. Yes. So already we have discussed. Next, come to next question. Yes, question number 14 is, what is the amount of work done in moving a point charge around a circular arc of radius r at the center of which another point charge is located? Yes, that means in question number 14, this is the circular arc of radius r. Yes, so work done in moving charge on EPS is 0. We know it. So W is how much? W is equal to 0. Simplest answer. So what you have to write? You have to write as per the question number 14. What you have to write? The amount of work done in carrying a charge. The amount of work done in carrying a charge on equipotential surface is always 0. Is always 0. This is the answer. Next, come to our question number 15. Yes, two charges 2 microcoulomb and minus 2 microcoulomb are placed at points A and B at 5 cm apart. Okay. So as for the given question, let's draw the rough diagram. This is your 2 microcoulomb charge. This one is minus 2 microcoulomb charge. Are placed at points A and B. A and this is point B at separation 5 cm apart. Okay. So depict an equipotential surface of the system. That means You have to find the point at which potential is 0. Yes, so let us consider point P is at a distance x centimeter from A, x centimeter from A. So what is the position of point P with respect to B? That will be 5 minus x centimeter. So this is your x centimeter. At P, net potential will be 0. At P V net is equal to 0. V net means V due to positive charge plus V due to negative charge, that will be 0. V due to positive charge कितना होगा? K into 2 micro divided by x 2 microcoulomb divided by x centimeter. Yes, plus V negative will be K into minus 2 microcoulomb divided by your 5 minus x centimeter, that will be equals to 0. So after solving, what you will get? Now see. So K into 2 microcoulomb divided by x centimeter is equals to K into 2 microcoulomb divided by 5 minus x centimeter. So after cancellation, K microcoulomb cancel, 2 gets cancelled out, centimeter also cancel out. Then we will get x is equals to 5 minus x. X is equals to 5 minus x. Yes, that means 2x is equal to how much? 2x equal to 5 and x is equals to 5 by 2. That is your 2.5 centimeter. This is the answer. Yes, okay. This is your question number 15. Next come to your question number 16. Okay, so question number 16 के हिसाब से देखो, it is asking why electrostatic potential is constant throughout the volume of a conductor and has same value as on its surface. Yes, suppose this is your conductor. Let us think this is your conductor. In first chapter we have discussed, you may go through the lecture, all the contents are available in my channel related to your first chapter. Yes, so if this is your conductor, let us consider this is your conductor. What is the electric field inside the conductor? Electric field inside the conductor is 0. So E inside the conductor is 0. We know E is equals to dV by dr in magnitude, that is 0. What is dV by dr? Potential gradient, electric potential gradient. But we know derivative of any constant quantity with respect to dr, that is equal to 0. So on comparing these two things, okay, on comparing these two, we can say potential is constant. So potential is constant. V is equals to constant. V is equal to what? Constant. That means inside the conductor potential is constant. And remember one thing, V is equal to constant, the potential at every point inside the conductor remains same. Okay, it means thus potential at every point inside conductor is same, and this potential is equals to potential at the surface of conductor also, and it is equals to potential at the surface of conductor. सो बात की एक बात याद रखो तुम लोग. सो V surface, in this case V surface is equals to V inside is equals to V center, all are equal in this case. Yes, all are having same value. Potential at surface of conductor, potential inside the conductor, and potential at the center of the conductor. Yes, that is same. So this is about your question number 16. Next come to question number 17. So why two potential inside a hollow spherical charged conductor is constant and has the same value as on its surface? Yes, just we have discussed electric potential. It is asking why the potential inside hollow spherical charged conductor is constant. Why it is constant? Because E inside hollow spherical charged conductor, that is equal to 0, and we know E is equals to dV by dr, potential gradient equal to 0, but we know derivative of any constant quantity is 0, so potential is equals to constant. Yes, so what is the basic reason of this question? Electric field intensity inside this conductor is 0. Yes, because of this reason the value of potential is constant, and this is equal to the, just I have written, potential at center, potential on the surface, and potential inside, all are same, whose value is equal to kq by r, whose value is equals to V is equals to 1 by 4 pi epsilon naught, that is k into q divided by r. I hope this is very simple for you. Yes. Next, come to question number 18. So why there is no work done in moving a charge from one point to another point on an EPS? What is the reason? On an EPS, potential remains same, potential at every point on an equipotential surface. Yes, on an equipotential surface, let us consider 2 points are there, A and B. Yes, so VA is equal to VB, at every point potential remains same. So don't write like this, simply write on an EPS, electric potential at every point is same. So potential difference कितना होगा? Delta V will be 0. Delta V will be 0. What is delta V? W by Q naught equal to 0. So what will be the work done value? That will be also 0. Yes, this is the reason. Next, come to your question number 19. Yes, what the question is asking? A hollow metal sphere of radius 5 cm is charged such that potential on its surface is 10 volt. What is the potential at the center of the sphere? Yes, the answer is ring. What is the answer? Simple. I will not explain. The potential answer is also 10 volt. Potential on the surface, potential at center, potential inside the metal sphere, that all are having same value. Yes. Next, come to question number 20. So next, question number 20. Can two EPS, equipotential surfaces, intersect each other? Justify your answer. Obviously no. And what is the reason? Actually, two equipotential surfaces never intersect each other. What is the reason? If they will intersect, then at the point of intersection, if they will do so, simply we can write, if they will do so, then there would be two values of potential, two values of electric potential at the point of intersection. Some students are writing this question answer in another way. We know electric field lines are perpendicular to equipotential surface. Electric field lines are perpendicular to equipotential surface. So if two EPS will intersect each other, that means perpendicular drawn to those surfaces, they will also intersect each other. And we know two electric field lines never intersect each other. If they will do so, then there would be two directions of electric field intensity at the point of intersection, which is practically not possible. Like this you may write the answer. So this is about your some 1 mark questions related to your chapter electric potential at capacitance. First we will discuss the electric potential question. After that we will discuss capacitance questions. Yes, this is about your electric potential 1 mark question. In next lecture we will discuss electric potential 2 marks question. Yes, so I hope this session is very clear to all of you. Thank you. Have a nice day.